So, graphing compound inequalities. Compound, what does that mean? Start off with there. You might have heard this in English class, writing a compound sentence. Right? Remember that compound sentence? It's when you take two sentences and you link them together and make them one sentence by combining with a conjunction, such as and, or but. So take two sentences and put them together. So for mathematically, it's the same thing. We're just going to take two inequalities and write them together. The only conjunctions we'll use are these two. And or. And we use it to describe, well, sometimes we just don't want to be below a certain number or above a certain number. Sometimes we want to be both, above a number and below a number. Okay, so this just addresses situations such as something like this. Okay. So turbulence, like in the airplane. Sometimes it gets a little rocky and things are shaking and you're like, well, just have to sit there and hopefully it stops, right? Well, certain really rough turbulence happens, roughly in the same elevations no matter where you fly, because that's where the high pressure and low pressure air come together and it's really, really, really violent. So that's what turbulence is, high pressure and low pressure air mixing up. So to avoid it, pilots fly higher than 35,000 feet. So above 35,000 feet would be that direction. Or they can be below it. So 29,000 feet or lower. Okay. So that means turbulence is somewhere between 29,000 and 35,000 feet. So this is a compound inequality. This is a compound inequality. It's two inequalities just on the same number line. Just like a compound sentence, two sentences just combined into the same sentence. Now you can see this is written or, and that's actually important. Our final answer here, how we'd write this answer, would actually be have the word or in it, okay? And it would be, and you just write both inequalities. Kind of like you take two sentences and you just write them as you would anyway and just put a conjunction between them. So we'd write x is less than 29 or x is greater than 35. And that would be the final answer. Looks just like that. It's a little different because it has this word in there, or, but we're really just combining two inequalities into one graph, into one solution. Sometimes there are more than two solutions, even. You can have three different solutions. Once we get into graphing inequalities, we'll look at what happens when there's three conditions. And this is another good example of how we already think this way. We see these all the time. Oh, it has to be bigger than this, but smaller than this. But you don't think, okay, that's compound inequalities from algebra. I never use algebra in the real world. Well, if you're thinking this way, that's algebra. You may not call it that, but that's what it is. All right. So that is a good example of compound inequality. Let's do another. Keep an orchid healthy. Gardener must keep temperature in the greenhouse greater than 69 degrees and below 78 degrees. So this is kind of different. This isn't saying below one and above the other. It's saying it needs to be above here, but below 78. So it's kind of like the opposite. What's another way of saying this? These are all the temperatures, what? What's that? Medium. Medium, good. Another one would be between. And these are all numbers just between. Has to be in this range, another way of saying it. The temperature has to be in this range, somewhere between this and this. That's like a range. The what? Well, median would be in the exact middle. We're talking about all of these. So, range. Okay. Be home between 4 o'clock and 7 o'clock. Same thing. It's a range, somewhere between. And we use the word and. When we have this betweenness going on, we use the word and. Okay. So we have two types. So must be bigger than the small number and must be smaller than the big number. Notice how these are open circles, so I have just strictly greater than, strictly less than. And this is one acceptable answer. However, only for the and compound inequalities, there is another way of writing this down. Okay. And I'll show you that right now and give you more explanation on the next slide. So another way of saying this, I'm going to use, I'll continue to use x. Another way of saying that is that my answers, x, can be between these two numbers. So you actually write your variable between the small number on the left, the big number on the right, okay? And bring down the inequality signs. Only catch is, over here it's the same, x less than 78, x less than 78. Over here it's kind of flipped around. We started off with x on the left, 69 on the right. If you flip it around, it looks like this. Imagine just taking this and holding up to a mirror and flip everything around, including the inequality sign, so you can see how it's now less than. So this means right here, all the numbers x between the low and the high temperature. And this is called like an in-between statement or a between statement. So this is how you really want to write all your answers that involve an and. Probably want to write it like this first, but then convert to this. As opposed to the or statements where you just write like that and that's it. No other way to write it. So again, a little more details. Anytime you have an and, so x is greater than or equal to 2 and it's less than or equal to 5. Just notice how this is the second one with a bigger number. It's the same thing, but here it's like flipping around. So the variable goes to the right, the number goes to the left, and even the inequality sign is flipped around. A few guidelines are right here. The small number is always on the left. Large number is always on the right. And you only use less than or less than equal to signs. These will never be pointing greater than. The logic doesn't really work if those are not both pointing to the left. So it's one or the other, less than or less than equal to. Usually they're both the same sign if they're both less than or equal to or both less than, but sometimes it can be one of each. So if you had like an open circle here, then that would just be less than only. So it just depends on the graph. You'll have two types of problems for your homework. The first ones are like these. They give you a word problem and you have to come up with the inequality, compound inequality and a graph. And the second will just be, what if I give you a graph, can you come up with a compound inequality? So kind of like the reverse. One asks you to find the graph, write it out. The other gives you the graph and asks you to write out the compound inequality. All right. So a few other examples. You tell me, would this be an and or an or? Number 3. Are these between or are they going away from each other? The graph's going away. Yeah, and. One word that gives it away I'm kind of covering right here is right here. Between. If you took your notes, I wrote between. So and is usually associated with between. Okay. So that helps you out, and it tells you what variable to use. So the recommended pH level. What is pH level? Yeah, acidity, you know this from science class. So yeah, it's kind of important that your swimming pool is not too acidic, otherwise when you get in there, your skin will fall off, right? So when pool guys or pool people come and actually clean the pool, or somebody cleans the pool, they have to test the water to make sure it's not too acidic, or they didn't put too much chemical in there, otherwise bad things actually happen. And if you don't put enough in there, then bacteria can grow. So you have to have that perfect balance where it kills all the bacteria and stuff that falls from the sky, bird poop or whatever else, might be in there. But at the same time, it kills the bacteria, but doesn't make your skin burn. Because you can get chemical burns if too much of it comes in contact with your skin, and it looks like a sunburn. It actually makes it turn red and irritates it, depending how severe it is. So very important to actually test the pH of water before you get in there, and assume it's just safe because you threw a bunch of chemicals in there. So here we go. Since it's in between, I know I'm just going to put here. I'm going to put my two inequality signs. Right, both are pointing left. 7.2 is smaller than 7.6, so 7.2 on the left, 7.6 on the right. Now the question is, should these be less than or equal to? And how do we know? There's one word there that for sure lets us know. Well, between just lets us know it's an and statement. But the other word is inclusive. That word inclusive means less than or equal to. It means it's between these two numbers, but it also includes those two numbers. So that word inclusive means less than or equal to in this context. It includes the numbers, which means it can be equal to those numbers. Since it can be equal to those numbers, we put, yeah. Okay, are we done with this problem? Yeah? Yes or no? How would you know if you're done with this problem? What does the directions say? So are we done? Oh, see how much easier it is to answer that question once we've read the directions. Many of you did not do that, and on your test, you wrote the equation down, never solved it. Just didn't read directions. So do a number line, put an arrow in either end, but we're not going to spend a lot of time numbering this. I'm just going to put the small number on the left, 7.2, bigger number on the right, 7.6. I'm going to note that these are both less than or equal to, so those are both solid, equal to. And between these two numbers, between 7.2 and 7.6, 7.3, 7.4, 8.1, 8.5, well not 8. Sorry, 7.559, everything between. And nothing bigger, nothing smaller. That's how you graph that. And now are we finished? Yes. And we know that not just by, some of you when I ask that question, you're like, I got a feeling we're done. So yeah, we're done. When I ask you that question, you should be looking for evidence to see if we're done or not. Did I answer the question? Did I follow the directions? Not just a feeling of, well, I've done a lot of work on this problem already. I should be done. Okay, let's try another. Kind of related to what we just looked at above. When you put chlorine in swimming pools to make sure it doesn't have bacteria growing in it, so when you get out of the pool, you don't have little critters on you that you can't see, little microscopic bugs that get you sick. You have to put a certain amount of chlorine in there, but to kill the bacteria, but not so much, again, that it burns your skin off. All right, so it's not like when you clean a pool, you can just take the bucket and just, I'm going to throw this much in there randomly and just hopefully that'll clean it. I'll put a little bit extra just in case. It doesn't work that way. You have to put a precise amount. Otherwise, bad things happen. You get sick from bacteria or you get burned from chlorine. And too much chlorine, even if you're not swallowing it, if it comes in contact with your skin absorbs it and it's poisonous. So another way of writing this, it says between again, so that's a good hint, and it says our variable is c. Okay. So you guys go ahead and write a compound inequality on this one. So you write down there. So we should have inclusive. It does say inclusive. Less than or equal to, both of them. 1.0, 3.0. Of course, the graph will look very similar. 1.0, 3.0. Inclusive, solid, solid. Notice it took me about 8 seconds to jot that graph down. You don't have to spend any more than that. Keep it simple. It has all the information we need. Make sure you circle these in all the way. Don't leave any gaps where, you know, if you do something like this, it's hard for me to tell. Is that open or closed? So closed means circled all the way in, no gaps at all, no chance of misinterpretation. That's good. Okay. Look at a few of the other. Okay, water is not a liquid state if its temperature is below 32 degrees Fahrenheit or above 212 degrees Fahrenheit. Good hint right here. Or. So how would you write below 32 degrees? What inequality sign? Greater than, less than or equal to, greater than equal to? Yeah, just less than. It doesn't say inclusive, right? What variable should be used here that would go along with the problem really well? What's that? YF. Okay, so Fahrenheit, that's the units, or T for temperature. Okay. That's the same thing you would do like in a science class. You'd use T for temperature. Or the temperature can be above 212 degrees Fahrenheit. No other way of writing this. That's the correct way to write the final answer because it's an OR statement. Go ahead and graph it. So number line, 32 on one side, 212 degrees on the other. Open or close? Open this time. Okay. Below 32 degrees, that's where it's frozen. Above 212 degrees, that's where it's a gas or water vapor. Going separate directions, it's an OR. Another way, somebody asked about this before, last period. Another way of thinking about this, like how do you know it's and or an or? Or is when one of the conditions are true. Meaning the water can't be less than 32 and greater than 212 at the same time. It's one or the other. Only one can be true. Whereas and is where they're both true. The water can be bigger than 7.2 and it can be less than 7.6 at the exact same time. So that's the logical difference with and or. If you're reading a word problem tonight, I'm like, well, I can't really figure it out. They're not using the words like between, you know, in the question, or the word or is not in the question. How can I figure it out? Are they asking both of these have to be true at the exact same time, or it's one or the other has to be true? And that will help you a little bit as well. So this is like the second half of your homework, where you have to actually read real life problems and write it in algebraic form. And I don't know, would you actually use this in real life maybe? Or does somebody use it in real life? Yes, absolutely. Whether it's the person actually doing this Or if it's somebody creating an electronic tester, you can imagine somebody made like an app or something that you just put in the water and it can measure it. Somebody would have to write the code with this mathematics so that if the temperature was actually between these two numbers, it would give you a green light, and if it was not between those two numbers, give you a red light. So one way or another, not that you're going to be all cleaning pools at some point, but there's a lot of different possibilities where you would have to actually know how to use this. All right, so let's look at just more basic, not real life problems with just a straight graph. So just looking at this, 6 and 7, is that an and or an or? Or number 6, number 7, and. So that's the first step, just being able to identify by looking at it. And the key characteristics are, okay, yeah, or is going separate directions and is connected in some way. All right, so for here, we just write the word or and write the two inequalities, small one on the left. So what's the inequality on the left side here? X less than or equal to, good. On the right-hand side, the bigger one. Use the same variable, and what do we got? Greater than or equal to 7. And below, x greater than or equal to 0, and x less than, just less than, because it's open circle, 6. Okay. But only with these and statements, you can rewrite it as a between statement. So this means all the numbers between 0 and 6, including 0. So another way of writing it, keep that the same, the bigger one the same, but over here we're going to flip it around, so that's going to become a 0 less than or equal to. So this means all the numbers x between 0 and 6. So we actually write it the way we say it. And we actually write the x between the 0 and the 6. And it means all the numbers between 0 and 6. Including 0, solid dot, including 0, so less than or equal to, open, strictly less than here. Those are two problems you'll be looking at, real life problems, and then just looking at the graph and deciphering what it means. Okay. Got lots of time. You might be able to finish most of this. So go ahead and get started.